Okay, the first thing that we want to do is to zero the force sensor, and you'll notice that I have a paper clip and a clamp attached to the force sensor. The paper towel roll will be attached to the clamp, but I want the force sensor to ignore the downward pull of gravity due to those two attachments. So I'm going to zero the force sensor. Okay, now that the force sensor is zeroed, I'm going to go over there in a few moments, attach the paper towel roll, and let it drop. And we should get then a force sensor reading which is equal to the tension in the paper towel as the paper towel roll falls. Okay, what I just did is I extended the time to well over a minute to give me enough time to scoot over there, attach the paper towel roll to the clamp, which is attached to the paper clip, which is attached to the force sensor. Okay, so here we go. Okay, so paper clip attached to the force sensor. Okay, paper towel roll attached to clamp. Okay, now all I have to do is release it from rest, and hopefully the force sensor picks up the tension in the paper. Okay, here we go. 1, 2, 3. Okay, so here's our force versus time graph. This is when I was preparing to drop it. And when I dropped it, okay, this is when it was falling, and this is probably when it hit. So what I'm going to do is I'm going to do statistics on this region right here. Okay, now let me just spread out the graph a little bit here. Let's see. Okay, I'll make this 43 seconds, and this maybe 42 seconds. Nope. 40 seconds. Okay, and I'm going to box in this region right here and do statistics. And it looks like I'm getting about 5.4 newtons, 5.4 newtons. So that represents the tension in the paper towel roll. And that's what you want to compare to the predicted tension that you found.